Maya and Steven are making party favors for their friend's birthday party. Maya made 20 favors before Steven joined her. She makes 10 favors every 20 minutes. Steven is trying to catch up with her. I guess he feels guilty that he was late. And he's working faster. He makes 1 favor per minute. After how many minutes will Steven have caught up with Maya? In other words, after how many minutes will they have made the same number of favors? So we normally have equations to work with, and we use slope-intercept form. That's the easiest way to graph an equation. Here we have a bunch of words. Okay, and so we can go through the tedious task of making an equation for each of these. But, truth be told, and don't tell anyone else this, you don't have to come up with an equation if you have a word problem that you understand. You can graph directly from the words without having an equation. So let's look at Maya first. So I'm going to use blue for Maya. So it says Maya made 20 favors before Steven joined her. Well, that means that at 0 minutes, because we're going to start the clock when Steven gets there. At 0 minutes, Maya had already made 20 favors, and that means that the intercept for Maya's line will be at 0, 20. Now, she makes 10 favors every 20 minutes, so that's going to tell me what my slope is. I'm going to go up 10 favors and across 20 minutes. So from 20, I'm going to go up 10 to 30 and across to 20. And I'm going to put my point. And then another 10 in another 20 minutes. And another 10 in another 20 minutes. And now I'm going to connect those by drawing a line. And hopefully this is linear. And there we go. And that's going to go on. So I need an arrow. Okay, now we're going to graph Steven's contribution to this party favor making session. He's starting down here. He's starting at 0, 0 because this is when he comes in. And he makes 1 favor per minute because he's trying to catch up. Well, our graph is kind of sectioned off at 5, right? We label every 10, so we can use our hash marks of 10. If he makes 1 per minute, he makes 10 in 10 minutes. So that would be here. And 20 in 20 minutes, 30 in 30 minutes, and so on. And there we go. And now we're going to connect these points. And it's not exactly perfect, but what you can see is that this is the point of intersection. The point of intersection is the solution to this system of equations if we had written equations. But again, we took a shortcut, right? We're not telling anyone, but you do not need to write equations in order to find the solution from graphing. What is the solution? Well, what's the question? We have to go back and look at the question. After how many minutes will Steven have caught up with Maya? Well, let's look. He will catch up after 40 minutes. Okay, and after 40 minutes, they will have both made, going back to the y-axis, 40 favors. And that's how we graph from a word problem, because normally we're trying to graph to find the answer to a specific question. And that answer will be found from the intersection. And again, if I wanted to give you an ordered pair for this solution to this system of equations, it would be 40, comma, 40. Okay, they will have made the same number of favors, 40 favors, after 40 minutes. And that's how we solve systems of equations from word problems without having to write equations.